Test Process Part 1. There is no one universal software test process, but there are common sets of test activities without which testing will be less likely to achieve its established objectives. These sets of test activities are a test process. The proper, specific software test process in any given situation depends on many factors. Which test activities are involved in this test process, how these activities are implemented, and when these activities occur may be discussed in an organization's test strategy. Test process in context. Contextual factors that influence the test process for an organization include, but are not limited to: 1. Software development lifecycle model and project methodologies being used. 2. Test levels and test types being considered. 3. Product and project risks. 4. Business domain. 5. Operational constraints, including but not limited to budgets and resources, timescales, complexity, contractual and regulatory requirements. 6. Organizational policies and practices. The following sections describe general aspects of organizational test processes in terms of the following: 1. Test activities and tasks. 2. Test work products. 3. Traceability between the test basis and test work products. It is very useful if the test basis, for any level or type of testing that is being considered, has measurable coverage criteria defined. The coverage criteria can act effectively as key performance indicators, KPIs, to drive the activities that demonstrate achievement of software test objectives. For example, for a mobile application, the test basis may include a list of requirements and a list of supported mobile devices. Each requirement is an element of the test basis. Each supported device is also an element of the test basis. The coverage criteria may require at least one test case for each element of the test basis. Once executed, the results of these tests tell stakeholders whether specified requirements are fulfilled and whether failures were observed on supported devices. ISO standard, ISO IEC, IEEE 29119-2, has further information about test processes. Test activities and tasks. A test process consists of the following main groups of activities: 1. Test planning. 2. Test monitoring and control. 3. Test analysis. 4. Test design. 5. Test implementation. 6. Test execution. 7. Test completion. Each main group of activities is composed of constituent activities, which will be described in the subsections below. Each constituent activity consists of multiple individual tasks, which would vary from one project or release to another. Further, although many of these main activity groups may appear logically sequential, they are often implemented iteratively. For example, Agile development involves small iterations of software design, build, and test that happen on a continuous basis, supported by ongoing planning. So test activities are also happening on an iterative, continuous basis within this software development approach. Even in sequential software development, the stepped logical sequence of main groups of activities will involve overlap, combination, concurrency, or omission, so tailoring these main groups of activities within the context of the system and the project is usually required. Test planning. Test planning involves activities that define the objectives of testing and the approach for meeting test objectives within constraints imposed by the context, e.g., specifying suitable test techniques and tasks, and formulating a test schedule for meeting a deadline. Test plans may be revisited based on feedback from monitoring and control activities. Test planning is further explained in Section 5.2. Test monitoring and control. Test monitoring involves the ongoing comparison of actual progress against planned progress using any test monitoring metrics defined in the test plan. Test control involves taking actions necessary to meet the objectives of the test plan, which may be updated over time. Test monitoring and control are supported by the evaluation of exit criteria, which are referred to as the definition of done in some software development lifecycle models. For example, the evaluation of exit criteria for test execution as part of a given test level may include: 1. Checking test results and logs against specified coverage criteria. 2. Assessing the level of component or system quality based on test results and logs. 3. Determining if more tests are needed, e.g., if tests originally intended to achieve a certain level of product risk coverage failed to do so, requiring additional tests to be written and executed. Test progress against the plan is communicated to stakeholders in test progress reports, including deviations from the plan and information to support any decision to stop testing. Test monitoring and control are further explained in Section 5.3. Test analysis. During test analysis, the test basis is analyzed to identify testable features and define associated test conditions. In other words, test analysis determines what to test in terms of measurable coverage criteria. Test analysis includes the following major activities. 1. Analyzing the test basis appropriate to the test level being considered, for example, requirement specifications, such as business requirements, functional requirements, system requirements, user stories, epics, use cases, are similar work products that specify desired functional and non-functional component or system behavior. Design and implementation information, such as system or software architecture diagrams or documents, design specifications, call flow graphs, modeling diagrams, e.g., UML or entity relationship diagrams, interface specifications, are similar work products that specify component or system structure. The implementation of the component or system itself, including code, database metadata and queries, and interfaces. Risk analysis reports, which may consider functional, non-functional, and structural aspects of the component or system. 2. Evaluating the test basis and test items to identify defects of various types, such as ambiguities, omissions, inconsistencies, inaccuracies, contradictions. 3. Identifying features and sets of features to be tested. 4. Defining and prioritizing test conditions for each feature based on analysis of the test basis, and considering functional, non-functional, and structural characteristics, other business and technical factors, and levels of risks. 5. Capturing bi-directional traceability between each element of the test basis and the associated test conditions. 6. The application of black box, white box, and experience-based test techniques can be useful in the process of test analysis, testing techniques, to reduce the likelihood of omitting important test conditions and to define more precise and accurate test conditions. In some cases, test analysis produces test conditions which are to be used as test objectives in test charters. Test charters are typical work products in some types of experience-based testing. When these test objectives are traceable to the test basis, coverage achieved during such experience-based testing can be measured. The identification of defects during test analysis is an important potential benefit, especially where no other review process is being used and/or the test process is closely connected with the review process. Such test analysis activities not only verify whether the requirements are consistent, properly expressed, and complete, but also validate whether the requirements properly capture customer, user, and other stakeholder needs. For example, techniques such as behavior-driven development, BDD, and acceptance test-driven development, ATDD, which involve generating test conditions and test cases from user stories and acceptance criteria prior to coding. These techniques also verify, validate, and detect defects in the user stories and acceptance criteria. Test design. During test design, the test conditions are elaborated into high-level test cases, sets of high-level test cases, and other testware. So, test analysis answers the question, what to test, while test design answers the question, how to test. Test design includes the following major activities. 1. Designing and prioritizing test cases and sets of test cases. 2. Identifying necessary test data to support test conditions and test cases. 3. Designing the test environment and identifying any required infrastructure and tools. 4. Capturing bi-directional traceability between the test basis, test conditions, and test cases. The elaboration of test conditions into test cases and sets of test cases during test design often involves using test techniques. As with test analysis, test design may also result in the identification of similar types of defects in the test basis. Also, as with test analysis, the identification of defects during test design is an important potential benefit. Test implementation. During test implementation, the testware necessary for test execution is created and/or completed, including sequencing the test cases into test procedures. So, test design answers the question, how to test, while test implementation answers the question, do we now have everything in place to run the tests? Test implementation includes the following major activities. 1. Developing and prioritizing test procedures, and, potentially, creating automated test scripts. 2. Creating test suites from the test procedures and, if any, automated test scripts. 3. Arranging the test suites within a test execution schedule in a way that results in efficient test execution. 4. Building the test environment, including, potentially, test harnesses, service virtualization, simulators, and other infrastructure items, and verifying that everything needed has been set up correctly. 5. Preparing test data and ensuring it is properly loaded in the test environment. 6. Verifying and updating bidirectional traceability between the test basis, test conditions, test cases, test procedures, and test suites. Test design and test implementation tasks are often combined. In exploratory testing and other types of experience-based testing, test design and implementation may occur, and may be documented, as part of test execution. Exploratory testing may be based on test charters, produced as part of test analysis, and exploratory tests are executed immediately as they are designed and implemented. Test execution. During test execution, test suites are run in accordance with the test execution schedule. Test execution includes the following major activities. 1. Recording the IDs and versions of the test items or test object, test tools, and testware. 2. Executing tests either manually or by using test execution tools. 3. Comparing actual results with expected results. 4. Analyzing anomalies to establish their likely causes, for example. 4. Failures may occur due to defects in the code, but false positives also may occur. 5. Reporting defects based on the failures observed. 6. Logging the outcome of test execution, for example. 6. Pass, fail, blocked. 7. Repeating test activities either as a result of action taken for an anomaly, or as part of the planned testing, for example. 7. Execution of a corrected test, confirmation testing, and/or regression testing. Test completion. Test completion activities collect data from completed test activities to consolidate experience, testware, and any other relevant information. Test completion activities occur at project milestones such as when a software system is released, a test project is completed, are cancelled, an agile project iteration is finished, a test level is completed, or a maintenance release has been completed. Test completion includes the following major activities. 1. Checking whether all defect reports are closed, entering change requests or product backlog items for any defects that remain unresolved at the end of test execution. 2. Creating a test summary report to be communicated to stakeholders. 3. Finalizing and archiving the test environment, the test data, the test infrastructure, and other testware for later reuse. 4. Handing over the testware to the maintenance teams, other project teams, and/or other stakeholders who could benefit from its use. 5. Analyzing lessons learned from the completed test activities to determine changes needed for future iterations, releases, and projects. 6. Using the information gathered to improve test process maturity.